The biggest challenge for engineers when constructing massive bridges over water is the water itself. Welcome back to another fascinating video. We cross over countless bridges every day, but most of us never notice the engineering masterpieces behind them. Compared to buildings, bridge construction is much more difficult. Buildings rest on a stable foundation, but bridges must withstand constantly changing loads, millions of tons moving from one end to the other. As the population grows, the importance of bridges and flyovers increases, and this importance multiplies when the bridge is built over water. Yes, while building bridges on land is already a challenge, constructing them over water is 10 times harder. Every millimeter is pre-calculated because even a tiny miscalculation can result in billions in losses and thousands of lives at risk. Whether it's houses, buildings, or bridges, they all share one thing in common: their foundation. Just as no structure can exist without a foundation, a bridge cannot stand without one either. But here's the real question: how is a bridge foundation built underwater? How do engineers work beneath the waves in deep oceans and rivers, where currents and water pressure create massive obstacles? And how do these foundations remain so strong that they hold the bridge firmly against water currents and storms? To construct a bridge over water, engineers first need to study the water's depth and analyze the ground beneath it. How deep is the water? Is the riverbed rocky or soft? To collect this data, professional scuba divers dive to the bottom of the ocean and spend weeks gathering information. If the water is shallow, the foundation can be built easily, but if the water is deep, the risks increase, and both construction costs and labor efforts rise tenfold. Once the data is collected, the biggest challenge is removing the water from the construction area. Yes, no matter how deep the water, it must be removed first before construction begins. But how is deep water removed? Engineers use 3 different methods for this. The first method is called the cofferdam. This involves blocking off the water from all sides using soil and sand, raising the level above the water. Once the perimeter is sealed, the water inside is pumped out, creating a dry area for construction. But this method is not always reliable. Sometimes the soil walls weaken and water pressure breaks through, flooding the site and endangering workers' lives. To solve this, engineers use steel sheet piling instead of soil. Steel sheets are driven into the ground, forming a strong barrier around the site. Once the bridge foundation is built, the temporary dam is removed. The second method is called the caisson. Here, the foundation is built on land and then transported to the construction site by ships. This foundation structure is box-shaped, sealed at the bottom and open at the top. If placed directly into the water, it would float just like a glass in water. To sink it, engineers follow a process. If the water is moderately deep, large stones are first dropped into the water to create a solid base. The foundation is carefully placed on top using cranes. Finally, the box is filled with concrete, making it heavier and more stable. But what if the water is even deeper? For extreme depths, engineers use the battered piles method. This involves using massive steel pipes to form a strong foundation beneath the water. First, these huge steel pipes are transported to the construction site by ships. But how do they drive these heavy steel pipes into the seabed? Each pipe weighs thousands of tons, far too heavy to be inserted manually. To solve this, engineers use giant hydraulic hammers mounted on massive cranes. These hammers continuously pound the steel piles, forcing them deep into the ocean floor. Once secured, these steel piles become so stable that even massive waves or hurricanes cannot move them by a single millimeter. Now, a solid underwater foundation is ready, and the bridge construction can begin. But this process is not as simple as it sounds. It takes years of effort and sometimes even costs lives. Now let's look at the 10 longest bridges ever built on land and water. Number 10, the Richmond San Rafael Bridge in the USA is 36 kilometers long. Number 9, completed in 2017, the Jiaozhou Bay Bridge in China is 37 kilometers long. It took 13 years to build. Number 8, built in 1956, the Lake Pontchartrain Causeway in the USA is 38 kilometers long and holds the Guinness World Record for the longest water bridge. Number 7, completed in 2010, the Beijing Grand Bridge in China is 48 kilometers long. Number 6, the Bang Na Expressway in Thailand is 55 kilometers long. Number 5, built in 2008, the Weinan Weihe Grand Bridge in China is 79 kilometers long. Number 4, the Kunshan Grand Bridge in China is 106 kilometers long. Number 3, completed in 2010, the Tianjin Grand Bridge in China is 113 kilometers long. Number 2, The Changhua-Kaohsiung Viaduct in Taiwan is 157 kilometers long. And now number 1, the longest bridge in the world, the Danyang-Kunshan Grand Bridge in China, stretching 165 kilometers. Astonishingly, this massive bridge was built in just 5 years. 10,000 workers worked on it at the same time, and its total cost was $8.5 billion. I hope you found this video informative and exciting. If you enjoyed it, don't keep this knowledge to yourself. Like and share it with your friends. Thank you for your love and support. See you in the next amazing episode.